Well, good afternoon, everyone. Welcome to the webinar. Today, Precision Agriculture Technology in Vegetable Production Systems. We're lucky enough to be joined by a range of guest speakers today, which we'll run through shortly, and the session's being delivered by the National Vegetable Extension Network, both in Victoria and Tasmania. Before we get started, just some housekeeping. You'll notice on your side panel there's a number of different functions. You can raise your hand and type a question which gets sent through to us, which you're more than welcome to use at any time. There's also a series of handouts there that we've got to download, which the presenters will walk you through when the time comes as well. And if you are having trouble with connection at any time, feel free to raise your hand and we'll try and sort that out for you. At the moment, we've got everyone on mute just so there's limited background noise. And we've got about 80 or so people joining us from around the country. So what is VegNET? VegNET is a national approach to getting research out on farms with growers, advisors and other service providers. There's 10 regional projects around the country. As I mentioned before, the Victorian and Tasmanian projects have partnered together today to deliver this webinar, obviously available to people nationally due to the delivery format, but really each region is engaging with growers and delivering communication and research information in a range of different ways. And that includes things like webinars today, but also things like fact sheets, regular e-newsletters, face-to-face workshops and masterclasses, and also things like case studies and sponsoring, awards for excellence and things like that, really with the aim of getting that levy-funded research out and adopted. So today's session, we're really lucky to be joined by John McPhee from the Tasmanian Institute of Agriculture, who will start today giving us a bit of an overview of PA, the what, the why, how and when, before Julie O'Halloran from Queensland Department of Ag is going to provide an overview of their new Hort Innovation project, adoption of precision systems technology in vegetable production. And we're really lucky too to be joined by Donna Forland from The Yield, who's going to be walking through quite a practical example where the rubber hits the road around their new growing conditions and sensing app as well. Just for our purposes, it's really interesting to know who's on the line. I'm just going to launch a poll now for people to quickly fill out. How much experience do we all have in using precision ag in commercial vegetable production? You'll have the option there to choose a lot, a bit, not much, or none, but keen to know more. It's just really interesting to see the breadth and diversity sometimes of participants on the line when we do have such a large group. So if you wouldn't mind just quickly filling that out now. And I can share those results back with you on screen. And a pretty broad mix. We've got quite a big cohort with a bit. Not many with lots, and then quite an even amount with not much and none, keen to know more. So look, that's really useful for us and the presenters just to gauge where everyone's up to. And without further ado, I might actually hand over to John to take us through the first part of this session.
Thanks for that introduction, Carl, and I'm glad to see those survey results there, because it's always a bit hard to know quite where to pitch with a thing like this. So looking at precision ag technologies in veg production systems, I'm going to start off with a sort of non-technical type slide, and that's about the precision agriculture mindset. If you're going to get into PA, you need to make a decision about the fact that you want to actually be precise in what you do, because PA management and technologies is not going to fix problems that are caused by ignoring the fundamentals. So if you're not getting things like correct seed depth spacing, depth or plant spacing and things like that, PA is not going to fix that. You've got to get the fundamentals right first. And also you need to think about why you want to do it, what are your priorities, what's your purpose. So it's about knowing the why, really. Now, we often talk about precision ag. A lot of people talk about precision ag. What we're really talking about, I guess, is more correctly termed site-specific crop management, which is a hell of a much bigger mouthful than precision ag. You've probably heard it spoken about in terms of like the right amount in the right place at the right time. And I guess that's really the core of precision ag. And it comes into things which I'll discuss a little bit more later about vari-rate applications and the like. And the other one that I heard just recently from somebody, it's about knowing exactly where you are on the planet and knowing what you should be doing when you're there, which I think is a pretty good way of looking at it. So why would we want to use this site-specific crop management or precision ag? We all know that things like soil vary across the paddock, nutrients vary, drainage capacity varies. So really it's about how we manage the paddock to its potential, given that there's a lot of variability in it. But it's also important to know whether or not this is the right choice. Is it the right pathway? Because going down this vari-rate approach requires you to understand, what is the type of variation you're looking at? Is it spatial or temporal? So does it vary across the paddock, or does it vary across time over the season, or even from this season to next season? Or maybe it varies in both of those parameters. What sort of degree of variation, and is it economically important to actually try to deal with it? I'll look a little bit later at some of the variation we're seeing in crops, which might raise a few eyebrows. What are the causes of the variation? You have to know what's actually causing the issue if you're going to try to treat it. And how suitable is the variability to be sort of split up into management zones? If your soil types in your paddock look like a Dalmatian dog, then you're probably going to have trouble getting management zones that can deal with all of that. And so the process is we observe variation. Now, a lot of people observe variation with their eyes, but we have technologies now which are able to get a much more nuanced picture of what variation is. So it'll be things like crop imagery or soil and yield mapping, those types of things. Then we need to understand what's causing it. You have to assess the causes, and this is what we often call ground truthing or validation, because if you don't do that, you're really flying blind. And then the vari-rate application bit comes in by putting in the right amount in the right place at the right time. A whole raft of tools get used. We see here a GNSS, I've called it, Global Navigation Satellite Systems. Most people probably think of it as GPS, but it's important to realise that GPS is just the American satellite constellation, and most systems now have access to GLONASS, the Russian constellation, and Galileo, the European one, and there are other more local ones sort of in the making as well. And that's really the foundation of precision ag. It tells us where we are. It helps vehicle and implement guidance. Then there are all sorts of mapping technologies, like EM38 for giving information about soil texture and moisture and salinity. We do grid mapping for things like pH and nutrients, digital elevation models that come off the topographical data, spectral imagery and yield mapping. They're all tools that get used in the PA space. From the perspective of in-crop imagery, there are a whole bunch of platforms that get used, right from satellites down to UAVs and ground-based rigs like tractors and so on. Vari-rate applications need vari-rate controller technology, and that's usually applied in areas like irrigation, fertiliser, seed, sometimes sprays for various things, particularly herbicides. And then we have machine controller systems, and primarily used in drainage and landforming, which is mostly done now using GNSS technology to give the sort of accuracy that we're looking for. So the precision ag activities can generate masses of data and masses of data layers. I've only included just a couple here, where we see an EM38 device being pulled along behind an ATV. and that will generate EM38 maps at both shallow and deep in the profile. But then down on the bottom right here, we've got a map of wetness index. Now that requires information on the topography of the land, and a lot of people might not be familiar or realise that that topographical data can be taken from your tractor guidance system. All tractor guidance systems collect that data. Some are a bit easier than others to get it out, but it's very, very accurate data for doing things like drainage planning and that type of thing. Speaking of drainage, I think drainage is probably one of the big overlooked things in precision ag, particularly in irrigated horticulture. And certainly some of the circumstances we have in Tasmania and southern Victoria can give massive returns on investment for dealing with drainage to get rid of waterlogging. Probably the place where most of the vari-rate activity started was in nutrient application, particularly in the broadacre industries, cereals and the like, where the normal approach is to take a gridded, to develop a gridded sample map and determine what the needs are, and then those that goes to make a vari-rate application map used in the fertiliser spreader. And here we can see a particular local example in Tasmania with a pretty reasonable return on investment for undertaking the task. Crop sensing is one that gets a fair bit of attention in the PA space. Obviously, crop sensing only happens during the crop growth period, and really it's about being able to monitor visible and near infrared light reflected from plants. A lot of clever people have developed a lot of vegetation indices, and DVI, normalised difference vegetation index, being probably the most common. It gives us information about the health of the plant. It can be used to do things like design vari-rate nitrogen application. But one of the important things to realise with NDVI and vegetation indices in general is that there are masses of them. There are literally hundreds of vegetation indices. And so NDVI is most commonly and most widely commercially used one, but it's important to understand that there are a lot of options there, and something like NDVI has been well used in the cereal and various grain industries, but oftentimes we don't quite know what it's telling us in some of the vegetable crops. So I think there's a lot of background research has to go on so we can understand better which particular vegetation indices we should use in particular circumstances. Crop sensing requires a bunch of technology. It's usually multispectral or hyperspectral cameras if you're talking at the research end for the hyperspec stuff. The little one on the top right there is sort of popular unit that comes from Microsense, often used on drones and the like. People might be familiar with the green seeker, which is used on tractor mounted or other similar mounted equipment. And one thing to think about in crop sensing, there are two basic, there's a division, if you like, in crop sensing technology between active sensors and passive. Active sensors like the green seeker provide their own light source, so you can use them under a wide range of conditions, whereas passive sensors rely upon just natural sunlight, and so cloud and things like that can interfere with the usefulness and validity of the data that comes back. Mentioned before a number of crop sensing platforms. They have their own pros and cons as to what's applicable in which location. Satellites certainly cover a large area, but there are places where cloud cover can be a problem, and the other ones just indicated there. Yield mapping is, I think, an important part of the precision ag space. Clearly, it's not it's a forward-looking management tool in terms of looking to the next season. Obviously, it's too late to do anything in that particular crop if you've got to the yield monitoring stage. But it can be quite a useful layer that helps you with future management. This particular image is from some potato harvest work that was done in Tasmania. and it shows up some quite interesting things when you look at it in retrospect. Those two long skinny rectangles on the right hand side were indicating an irrigation problem in the linear, I think it was from memory, in that paddock. So that was something that the grower could go back, obviously didn't help him in that particular season, but he could go back and check that before his next crop. The large rectangle on the left is a rather interesting circumstance, and I'm sure there were some very terse conversations had about it. At that line that separates the blue from the yellow, the grower was delivered a new batch of fertiliser mix, and it seems quite apparent that there was something lacking in that batch because the crop performed not nearly as well on that side of the paddock. So I imagine there was some interesting post-season conversations to be had around that. So yield mapping can be quite a good diagnostic tool for things. Just a quick wrap up, we've got a project happening in Tasmania which is looking at a series of on-farm sites spread across our growing region. We're looking at various things to do with precision ag, but the one I wanted to highlight here today in this red box over on the right hand side is the degree of variation that we see in crops. And you can see it's ranging from about a 2-fold difference from minimum to maximum yield up to a 20-fold difference in some crops. And those sorts of variations are not at all uncommon in vegetable crops, and I suppose it does highlight what the opportunities are for precision ag techniques, and also, as I said right at the start, getting the fundamentals right. Sometimes people wonder about how does the yield variation transfer from one season to the next. And here I've just plotted up we've got a few paddocks where we've had 2 successive crops. And so on the y-axis is the 2017 crop, on the x-axis the 2016 crop. You can see generally that low yielding areas in one crop become low yielding areas in the other crop as well. And there's a sort of a trend to the similar thing at the high yielding end, but you can also notice a fair bit of noise in the middle. So on some of these I've looked at in more details, sampling areas easily 50% might change from an above average to a below average yield from one crop to the next. And the other thing that we're doing in this project is we have an annual PA Expo held in April, and it's a great opportunity for people to come together and talk PA, look at products, talk to consultants and so on and so forth. And at that point, Carl, I'll hand back to you.
Yeah, great. Thanks, John. Just a reminder too, at the end of every presentation, we will take some question and answer session with the presenter, so you don't have to hold on to your questions throughout. So feel free in that sidebar to type in your questions for John. While we're waiting for a couple to come through, John, given our earlier poll that showed there was quite a few probably in the middle to lower spectrum around experience with PA, where do you start out in looking at what's appropriate, what's fit for purpose in a vegetable production system?
Okay, where do you start out? I think you start out by being able to identify some issue that might be able to be addressed with PA technologies. One that often arises is the issues of drainage. There's a great saying in the veggie industry that water on, water off. So getting the right amount of water on at the right place at the right time, which may mean vari-rate irrigation, particularly if in an area with highly variable soil types, and getting rid of water that you don't need, whether it be from winter rainfall, summer rainfall, over irrigation, whatever. So water on and water off, it's a fairly fundamental principle in irrigated agriculture, but one that can be greatly helped by precision technologies. Now, I'd probably, in the irrigation space, irrigation drainage space, it's really stuff like accurate topography mapping and soil mapping and vari-rate controllers.
Oh, good to know. So driving it from a particular problem that needs to be solved or objective in the first instance, perhaps rather than technology itself.
Absolutely, absolutely. Look, you can spend your life and your life savings buying technology, but unless you know why you're doing it and what purpose you're putting it to, it's becomes a bit superfluous, really. I'm sure there are lots of bits of technology sitting in back rooms unused because they've been bought out of interest, but not really knowing what was going to be done with it.
A question we've had come through, John, is around what are the main challenges that growers actually face in implementing precision ag?
Okay. Having made the decision to go ahead, I guess, look, interoperability is the word that rolls off everybody's tongue. There are so many makers out there in the market doing stuff, and everybody's unit's got some feature that's better than somebody else's, but so many of them don't talk to each other. And by that I mean you've got you might have a guidance system that's come with a particular coloured tractor, and then you've got some other vari-rate controller that's come with another model of something, and they won't work together. So that's a common problem. It's hopefully a reducing one. I think the industry's starting to understand that they need to do a few things about that, but it is a common one for sure.
Yeah, okay. And when you start using SSCM, do you need to adjust your rates or management over time as the variation is reduced?
That's a good point. I suppose it depends on what you're doing. If it's irrigation, for example, then you'll develop an irrigation prescription map based on soil type and whatever. You should really be adjusting that as the season goes on and demands of the crop change over the season. And the quite experienced people do that pretty much on a weekly or fortnightly basis. When it comes to things like nutrients, yes, you would want to be, some change more rapidly than others, like nitrogen versus lime, for example. But yes, you do need to revisit your nutrient mapping over time to ensure that you've still got the right prescription map in place.
Yeah. We've got a couple of questions through from Andy Gulliver over in Western Australia, just saying, what should we allow as a budget to get started with this technology in vegetable rotations? I guess it's how long's a string, isn't it?
How long's a piece of string, yeah. Okay. Look, well, the first thing you need is guidance, some sort of guidance system. I mean, preferably RTK, which gives you the 2 centimetre accuracy, but if not, then you probably want to be down in veggie systems. You probably don't want to be any more than 10 centimetre accuracy. And so, yeah, I mean, it depends whether you're going to write that cost into your PA investment, because a lot of people buy them for convenience of driving anyway. But, it's not hard to spend 40 grand on a guidance system, really. Then it's going to depend on which direction you're going. You're going, fertilizer, vari-rate fertilizer, for example, and you can certainly talk well in the thousands for vari-rate controllers, provided your machine's vari-rate capable. A lot these days are coming with the technology on them, and you just have to basically get it working, and then. You get up into yield monitoring, for example. Well, it's not hard to spend 10 or more grand on yield monitors, depending on what the type of machinery is. So that's not an easy question, but it doesn't take long to rack up. So hence coming back to what's the purpose? What's the key thing I'm wanting to try to address?
Excellent. John, we've got a couple of other questions through, one specifically relating to adoption, which I'm going to hold over to the next speaker.
Thanks for the introduction, Carl. As Carl mentioned, I'm from The Yield. We're an ag tech company based out of Hobart, but working nationally. And what, if it lets me, there we go. So we're an ag tech company that's been around for just over 2 years now, so we're still quite young in the market, and what we're looking at doing is how can we bring technology into agriculture in a way that we're actually solving immediate problems and looking at, sorry, I'm getting flashing errors about the webcam, so I'm not sure if it's working. Okay, there we go. And we're on a mission to transform food and farming with sustainable digital technology. And leading on from what John was saying, we're really in that sensing space of understanding what's going on in your environment, and then I'll sort of explain what flows on from that later as we go through. So looking at this slide from right to left, we have 3 products that we have available. The first, the one on the right, is our Free Growers app, and we have, and I'll touch on this a little bit later, we have an application available in the market for both Android and iPhones that's available for anyone to download for free. And what it does is it takes publicly available Bureau of Meteorology information and translate that into more relevant information for growers. So it's not aimed at the general public, it's aimed at growers and looking at what's actually happening in your area. It also provides evapotranspiration data, both in the past 7 days, today, and the next 7 days. And that's all built off that Bureau of Meteorology data. We also have our Sensing Plus for aquaculture in the market. Now that's been in the market for a year now, and it was our first foray into sensing technology and what that means. And what it's done, it's allowed us to develop our platform and develop our technology, which I'll explain in a bit more detail. And that's being used where we're collecting the data in estuaries where they're growing oysters. And we're presenting that data via 2 applications, one back to oyster growers to help them with productivity, to manage their harvesting, to manage their labour. A lot of their scheduling of their activities is contingent on weather conditions, so what's actually happening around the waterways is really important. But we also collect salinity information about the estuaries that gets then fed into the food regulators, and then they can use that to make decisions on when to open and close oyster growers for harvesting. So that was sort of our first foray into sensing and looking at how we can use that data for prediction and analytics and providing insights. And we use the same data to help two different users of the system. And what I'll be talking about today is actually Sensing Plus for agriculture, and that's our new product. We'll actually be in market with that in October, so it's not quite available just yet. But it's what we're working on, and that's what I'll talk you through. And what we're looking at is then taking what we've learnt from the aquaculture sensing environment and expanding that and using that platform into agriculture. So our on-farm ecosystem is made up, and I'm going to go left to right now to take you back across the screen, is made up of a series of sensors where we're collecting data for your on-farm microclimate. So that's looking at soil temperature, soil moisture, air pressure, wind speed and direction, leaf and berry wetness, relative humidity, soil conductivity, evapotranspiration, solar radiation, delta T, PAR, which is your photosynthetic active radiation, and air temperature. So we're looking at all of the conditions that influence growing and how well your crops are doing, and can give you information, insights into what's happening in your microclimate on farm. We then collect that data through our farm gateway. Then it gets transferred to our platform, which is hosted in the cloud, and then made available through our application. Now, the key elements of our system is really the 3 circles on the right of the screen here. What we do is we sense, we then take that data that's come from the sensors and we analyse it. Now, in that analysis, we're then able to do predictions. And this is really where the strength is, and this is what we've really built up through our experience in aquaculture is how do we take the data and then create predictions that are useful to help then inform the decisions that are being made day to day. Now, we're collecting a lot of data, and we're working quite closely with growers to work out what are the predictions that are actually useful. Now, the predictions that we'll have available immediately with the application in October is your local growing conditions. So temperature, rainfall, wind speed, wind direction, relative humidity, and then ETO and ETC. Now, these are the predictions that, working with our growers that have been feeding into this process have said that these are the critical ones initially to get built up, and we'll be then expanding our set of predictions. And those predictions are for today and the next 7 days, based on your on-farm environment. And for an example, this is what it would look like in the screen. We take that data and then we just provide a single prediction to help you then plan out for the next 7 days. Now, predictions are all well and good. They give you more data to have a look at, but where they become really powerful is when they get turned into insights. What does it mean from the predictions of wind and rainfall for things like spraying? What does your water balance or your evapotranspiration mean for your irrigation? So what we do is we take that and then translate that into what does that mean for the next 7 days for you. So it's not just then a wind prediction or a rainfall prediction, it's when is going to be the optimal time to spray? What is your water balance over the next 7 days? And then we take that and we automate them. We provide some help in that area so that it's not up to the user to have that all in their head and be thinking ahead. We help you set up notifications that might tell you when it's optimal for spraying or when it's not optimal to spray. When the wind conditions are going to be such that you're not going to be able to spray, and then provide that via text message or notifications in our app. Now, the two areas we're really focusing on for this first release in October is irrigation and spraying. Now, I think John also mentioned interoperability is the word of the day, and that's something I think the industry as a whole is aware of, and we're moving in that way. But in the short term, what we'll be helping the users into inputting their irrigation information so that we're more accurate to know exactly what's going on farm, and therefore what needs to happen over the next 7 days. But also in the spray, we're helping growers by allowing them to upload their inventory for spraying, to do their compliance reporting in terms of what the conditions were at the time that they've sprayed, and we capture all that information because we're capturing all the on-farm data, so we help simplify that process. One of the strengths of the product and the process that we go through is that we co-design with growers. We work with the growers day in, day out. We have our business analysts who are designing our system actually out there with growers in their tractors while they're harvesting, while they're spraying, while they're picking, and we've done that across crops. So we've got a focus we've got both annuals and perennials, and then within annuals, multiple types of crops from cauliflower to potatoes, etc. So, and our philosophy is that we need to work with growers so that we're actually solving problems and helping them with information they need to help them make decisions on farm. And the way we see the technology working is it's there to supplement and complement the way that growers work. So we don't only look at the data, but we look at, that they're busy and it needs to be able to be used one-handed on a mobile, while you're in full sunlight. So what does that mean for the design? And we're in the process at the moment of field trials for this, where we're refining it and doing new releases every month with the feedback that we get from the growers who are actually using this. So that's what's coming up for October for Sensing Plus. But what we have available at the moment is our Growers app. It's available via the Apple App Store or Google Play Store, where you can go in, download, and what it'll give you is today's evapotranspiration for your area. So you pick your closest bomb weather station and it'll do the calculations for you. It'll give you today's conditions. It'll give you the past 7 days, so you can have a look and see, how's it been going over the last week, and then it will give you a prediction for the next 7 days. Now, this is all based on the Bureau of Meteorology data, and it's so it's up to date as it can be from the Bureau of Meteorology, and it's readily available. So feel free to download now. And that's it from me.
Great, thanks Donna. A really nice practical overview there of what PA looks like in practice. We've had a couple of questions come through. What is the farm gateway, and how does this work on farm in a practical sense?
So what the farm gateway is it's where we collect all the data, and we have it in a single point that then gets sent to the cloud. Now, what that actually allows us to do is if there are connectivity issues for any reason, you know, for example, Telstra's lost connectivity in your area, it actually means the data is saved. It's never lost. It's sitting on farm, and you'll be able to access it directly from the gateway. So it provides that central hub where we can offer some extra functionality for when potentially, you know, things are offline. So you can still access your data and still get access and still see what's happening. And it also provides us with some capability to give you immediate alerts. So you don't have to wait till data gets transferred to the cloud, gets processed. We can do things on farm so that if you need to know something right now, you can find it out straight away.
Yeah, great. We've also had another question come through. Will the app allow growers to enter information about soil texture for estimating soil water and refill points?
It will long term. We see a long list of features that we want to get into the app. Initially, we'll be doing soil type to just help us do the soil moisture analytics and predictions. But we do have on the roadmap coming soon after soil texture, you know, looking at refill rates, available water, etc.
Yeah, great. And James Brinkhoff's sent through one last question before we move on. How important is microclimate versus a single weather station at a point on a farm?
So we've found that microclimate, it obviously depends on your situation, your climate, what you're growing. We've found it to be actually very important. Some of the growers we're working with, through data, have been able to determine they actually have 3 distinct microclimates, and the conditions vary significantly. And it helps them explain, you know, potentially why they've had a yield difference across their environment, why there's been disease outbreaks in certain areas and not others, and it just gives the information to know exactly what's going on. It's a little bit of what John said of, you know, you need to work out why you're measuring. And if you've got a reason why, because you've got a variance, we've found it's because of microclimate differences. And you're not going to pick that up with just a single weather station on your farm.
Yeah, great. Thanks, Donna. And James, hopefully that answers your question. Just due to time and that brief technical difficulty we had, and thanks for bearing with us during that, we'll now look to pass over to Julie O'Halloran.
Okay, thanks, Carl. As mentioned, I work for Queensland Department of Agriculture and Fisheries, based in Gatton in southeast Queensland. I'm just going to provide a brief overview of where we're at so far with VG 16009. So that's a project that's all about adoption of precision ag technologies in vegetable production. It's funded through Hort Innovation and the Vegetable Levy, and it has multiple project partners. So you can see down the bottom, University of New England's involved, Tasmanian Institute of Agriculture, Primary Industries and Regions South Australia, Harvest Moon, Vegetables WA, and the Society of Precision Agriculture Australia. So just a little bit of background. This is an adoption project, and Queensland DAF has had a previous project through a federal innovation grant from 2014 to 2016. So that particular project was about setting up numerous case study sites looking at assessing spatial variability in vegetables, and some of those things that John was talking about before, like does it exist, to what extent, is it worthwhile actually doing something about it, things like that. So that's what that project was really all about. We retrofitted some yield monitoring equipment to carrot, potato and sweet potato harvesters and looked at lots of situations for variable rate applications. And I just wanted to sort of highlight this one here. It's a very simple example of PA in vegetables. So it was grid sampling across this potato pivot for pH. From that pH data, which showed a variation in pH from 4.5 to 5.9, that grower was able to come up with a prescription map. So where he normally would have broadcast lime to a total of 60 tonnes across that block, he was then able to target where that lime needed to go to achieve a pH of 5.5 across the field. So that actually resulted in a 40% lime saving. So that's just a really simple example. It didn't involve lots of implementation of technology. In this case, there was a variable rate spreader in the region that he was able to use. So it was just a very simple and nice case study of how precision agriculture techniques and practices could be employed in vegetables. So getting back to the current project, so basically what we're doing is a similar sort of thing but at a national scale. So we're taking commercially available precision ag technologies and practices and putting them in place in vegetable farms across Australia and looking at how can these be applied to vegetable production to make management decisions. So we actually want to get information that's going to help people be more efficient in their production and yield and make management decisions on farm. So we will be involved in the installation of these technologies. John sort of touched on before that a lot of these technologies are sort of marketed as plug and play, but it's not usually that simple in terms of getting them on farm. So they can require quite a bit of optimization to get them to function the way they're intended to function on farm. So that does require some optimization. And ground truthing is also critical. So these are really just tools to provide more information about what's going on in your fields, and it's not meant to be a substitute for actually getting out there and having a look at what's going on in the field. So you really need that to work out what is this spatial data telling you. And obviously what we also want to know is the cost-benefit analysis and the return on any sort of technology investment. So as I mentioned, we have a range of demonstration sites around Australia. So there is a dot up in the Northern Territory. We don't actually have a demonstration site there, but we will be doing some communication activities there. But the rest of those dots on that map are where we currently have demonstration sites. With each of these demonstration sites, we will work with the grower to put together a farm action plan. So that identifies the priorities for the grower in terms of what they want to get out of the PA process. And the roles and responsibilities. So what sort of technologies are we going to apply? Who's going to do what? Things like that. So we go through those sort of steps with each grower and come up with a plan specific for their site. Then we go through a process of assessing the variability on those farms and ground truthing what that variability might be due to. We also have some work going on at some sites with yield mapping and also yield prediction, and I'll touch on that a bit later on as well. And I suppose they're the main sort of steps that we've been working with to date. The project only commenced in January, so we're still in the very early stages, and hopefully as we get more data around that variability and what's causing it, then we can start looking at management options and cost-benefit analysis later on. So when we're assessing variability, there's a range of tools that we can use, and John mentioned lots of these in his presentation. So I'm just sort of pulling data out from some of these demonstration sites to illustrate how we're doing this. So that's the WA site, and it's sort of showing how we've sort of used some EM soil mapping and radiometrics over there for the sandier soils, collected a whole range of crop sensing imagery there for that particular farm, and then sort of then drilling down to the individual field level and having a look at what's going on there. So this area, the pink areas are areas of high biomass. So this is high resolution satellite imagery, and the pink areas are high NDVI, which is indicating higher biomass, and the other areas, the yellow and the orange, are indicating lower areas of biomass. So as I mentioned, there's then the process of ground truthing. So some of the ground truthing activities we do get out there and do some GPS sampling, so just sort of locating points in the field in each of those NDVI zones, whether it's low, medium or high. There's some hyperspectral imagery going on, so that's very much a research tool at the moment, and that's the component of the project that UNE is working on. It's lots of soil sampling and yield assessment. So this photo down the bottom here is just an example of a low biomass area and a high biomass area in some of those yield assessments that we're doing. So in terms of some of our demonstration sites, I've just sort of pulled an individual field from each of these sites. Obviously we're getting lots of data from across the farms, but there's sort of too much to show here today. So Western Australia, we're working in a carrot farm, and in terms of what that particular grower is interested in, he's interested in obviously assessing what sort of level of spatial variability he has across his field, and they will be installing a yield monitor onto their carrot harvester at a later date, and they also is potential for variable rate irrigation there. It's very sort of slopey country, and even though it's quite sandy soil, you can still sort of notice differences in water holding capacity and water logging, things like that, as you walk across some of these large pivots. So we started at this site with some high-res satellite imagery down here, and we've just pulled some carrots and taken some yield samples from, I don't know if you can see, all of these little labels in this field are different points, sampling points. So there's 6 in the high NDV area, 6 in the medium NDVI zone, and 6 in the low NDVI zone. And we go out and sample at those points for soil, yield assessment, things like that. And so this is just some of the data that we've taken. It's just a handheld yield assessment, so it's very preliminary data. And that's just sort of showing the difference in the yield that we're sort of getting in the carrots between the high, medium and low NDVI zones. So if you roughly look there, it's about 30 tonnes or just under 30 tonnes per hectare difference between the high and the low NDVI zones. As part of our ground truthing to try and understand what might be going on and causing that variability, we have installed wild eye soil moisture probes. This is like a Google Earth image about where they've been installed in this particular field. You can see some sort of textural differences and soil colour differences just in that image there, and that's just a photo of how we've installed them at different depths down the profile. So we're still in the process of collecting lots of data, so we don't actually have a lot of results, and most of what we have is preliminary, but it's just a snapshot to show you what we're doing. Also at that same site, this is part of the work that UNE is doing as part of the project. So they're really looking at yield prediction. So can we predict yield from the crop sensing imagery? So this is that same high resolution satellite imagery with the sampling points. So those hand harvested yield assessments that we do, they then have a look at that and plot those against the NDVI values in the low, the medium and the high zones to have a look at what is the relationship between that crop sensing index and the actual yield that we're measuring in the field. From that, they can then develop an algorithm that they can use to predict or forecast yield. So at this site, they've actually been able to forecast a yield of 63 tonnes per hectare, and the actual yield data from this field from the grower is 61.8 tonnes per hectare. So that's quite a good relationship, I suppose. It's very, very early at the moment, so we do need to sort of test this. This is only one field. It needs to be tested across different soil conditions, different growing seasons, different growing areas, things like that, and different levels of variability to see how that relationship holds up under sort of all different sorts of situations. So it's very preliminary, and from that sort of equation, they can then sort of derive a predicted yield map. So that's sort of what that looks like. And then you can sort of break that data down even further and go, well, okay, so what sort of area is in the high zone, and what's the predicted yield of that high zone, and what's that sort of total percentage of the yield. So it allows you to then be able to break down that field area into different categories of yield, I suppose. So in that particular case, we sort of estimated that there's a potential loss in productivity of 15% across that field just from those lower biomass areas. So, but that is still very preliminary work. But that gives you a snapshot about what we're trying to do in terms of the yield prediction as well. Also over in WA, we have a brassica site. So So this particular farm consisted of some new development here and existing development. So this new development area was previously strip mined, and so this is the first time it's going to be sort of used for vegetable production. So we did undertake some EM38 soil mapping of both the new and the existing development, just to sort of see what sort of soil variability there might be. And obviously with the strip mining through here, we weren't sort of sure how well everything had been put back the way it was supposed to be. So he just wanted to get an idea about what might be going on in terms of soil differences before he actually started production. We have also undertaken some UAV or drone crop sensing imagery here. So this is NDVI for this particular pivot down here. Below this black line is actually the same planting date, so there is a bit of change in terms of the biomass there, which may be related to soil type differences along this creek here. So we're currently in the process of ground truthing this imagery and this EM38, so that's sort of about as far as we've got with that side at the moment. But this grower is also particularly interested in the opportunities for variable rate applications to maybe improve uniformity across his crops. Over to South Australia, this is another carrot site here. We do have another brassica site in South Australia as well, but we haven't sort of started the project activities there yet. So I just wanted to demonstrate here how there is a range of existing spatial data out there that you can sort of access to see what might be going on in some of your fields. So this is actually just a Google Earth image. You can see some of the soil type differences from that. This is just a dryland cereal yield map of the same pivot. So again, the same sort of spatial patterns are going on in terms of the cereal yield. And this is an onion yield map under variable rate irrigation. So they have put variable rate irrigation in place here to try and alleviate some of this spatial difference, but you can still sort of see that there is a little bit of variability going on there. So they did have existing EM38 imagery for this particular field, and this is it here. So this is down to 50 centimetres and this is down to a metre. So there's obviously some changes in electrical conductivity down deeper in the profile here. We're currently ground truthing this imagery at the moment, so we've sort of done some sampling in these different zones here to try and work out what's going on there in terms of differences in texture, but also potentially whether these blue areas is a bit of a salinity problem and things like that. So we're still waiting for those results to come in, so still very much in progress as well. This site will also get some high resolution satellite imagery. We're obviously just waiting for these activities are sort of dependent on what's going on in terms of cropping cycles and cropping season. So haven't quite entered carrot season down there yet. So we're just sort of waiting for that to get going later in the year, and the high res satellite imagery will happen there. And a yield monitor will also, they're also going to install yield monitoring equipment on their carrot harvester, and they're also looking at the potential for variable rate applications depending on what sort of is shown by some of this spatial data and ground truthing activities. In southeast Queensland, so we have just finished some ground truthing in southeast Queensland. It was high resolution satellite imagery in carrots again. So this is just one of the fields that we've been ground truthing only last week. So again, we had the 6 sort of sampling points in each of those high, medium and low zones in this particular field. We just pulled some plants out so you can sort of see what's going on, what that actually looks like. So they're sort of low biomass, medium and high. And in the preliminary yield data, we're actually sort of finding, this is very preliminary, I only sort of did the calculations yesterday afternoon, so it's very preliminary. So it's sort of indicating that there might be slight differences in the biomass, but the yield is not too far apart in terms of the medium and the high, and then the low is a little bit, quite a bit lower in terms of the yield. So still a lot of work to be done there in terms of processing that data, and UNE is also doing that same sort of yield prediction work at these sites as well. There is an existing carrot harvester with a yield monitor on, so we'll be taking that yield mapping data and comparing that with the yield prediction stuff as well, so, and these other spatial layers, and seeing what sort of relationships we can come up with between things like EM, the crop sensing imagery and yield data. This group's also interested in the potential for variable rate applications, so that will be something that we're also looking at down the track. I suppose the other part of the project, so some of these Queensland guys and also in the other demonstration sites have data, spatial data from previous year. So this is just sort of an example. This is green seeker data from 2015, a yield map from 2015, EM38 soil mapping from 2016, and then high resolution satellite imagery from 2017. So if you can sort of have a look, it's the same sort of spatial patterns across those particular blocks. So that's something that we're also wanting to have a look at, is collecting some of this long-term data to see what's going on over time, and then analysing those different layers to see how can that help explain what's going on in terms of variability as well. That's pretty much all I sort of wanted to talk about, just a bit of a snapshot about what's going on at our demonstration sites. It is an adoption project, so there will be lots of communication activities that's going on in conjunction with these demonstration sites. We'll certainly be working in with VegNET activities wherever possible, and also trying to foster linkages with PA service providers in the regions as well to sort of help with some of that troubleshooting and getting technology working the way it's supposed to on farms. So if there's any questions, yeah.
Great, thanks Julie. And just in on 1:30, so we're a little bit tight for time, but I want to make sure we do get some questions in before we finish up. One that we had through, Julie, was can people easily get biomass imagery online?
Probably not easily online. There is sort of free satellite sort of imagery, so it sort of depends on where you are and what's available in that area.
Okay. And just around topographical data, is that utilised when assessing variability at the demo sites?
Yeah, so that's another layer that I didn't show, but obviously that's something that's either collected through individual tractors, or it can be collected as part of the EM process as well. So we do have those data layers, and that is part of that, I suppose, looking at combining all the different data layers for a particular field and trying to work out what's going on there in variability. And certainly within that site where we've got those soil moisture probes, that would definitely be an overlay to try and work out, well, what's going on and the potential there to manage that variability.
Yeah, great. There was a question about one of your earlier slides, the example you had around pH. Would pH samples still need to be taken by hand, or are there digital methods to do that?
There are handheld pH meters that you can get, which are probably accurate enough for that sort of thing. And I know we've certainly had growers in southeast Queensland use those. So that, yeah, it doesn't have to be a complex process of soil sampling and sending them off. So there are actually portable meters that you can purchase that can do that for you.
Okay, great. Well, Julie, thank you very much for that presentation, and also a big thank you to John and Donna for their presentations. We really appreciate the time they've taken in preparing and delivering those today. If you'd like to find out more about VegNET or keeping in touch about any of the extension activities in any of your states, please feel free to get in touch. We've got some contact details and websites up on the screen there. There's a number of upcoming activities similar to this, and they're 3-year funded projects with the vegetable levy and Hort Innovation investment as well. But we've gone a couple of minutes over the session duration just with that technical glitch. So thanks for sticking with us, and we hope to see you at an event soon. Thanks everyone.